Sequences with missing terms, notes. The table below is for a sequence. There are only two terms given. Fill out the rest of the table, write the equation for the sequence, and then prove that it works. So, we left out a term between the first and third terms of the sequence. So we need to figure out what would go in this spot. Once we have that figured out, we could figure out how to fill in the rest of the table. So here's what we do. It's kind of like slope. We're going to take 18 and 6, the two terms that we have in the sequence, and subtract them. And we're going to take the term numbers for the same two terms and subtract those in the denominator. So the change in the sequence was 12 units, and the change in the terms was 2. So 12 units in two terms, I divide those, and I get a change of 6. That means the sequence is increasing by 6 every term. So now I can fill in the missing term because I would take 6 and add 6 to it and get 12. If I add 6 more to 12, I get 18, so I know that it's working. And now I can just fill in the rest of the table. So the 0 term, instead of adding 6, if I go backwards on the table, I would subtract 6. So that would be 6 minus 6 is 0. Going forwards on the table, 18 plus 6 would be 24. 24 plus 6 would be 30, 36, and 42. And now I can write the equation for the sequence. Remember, we write t sub n equals the change, which is 6, times n. And then we always start with the 0 term, but in this case, that's just 0. So I could write it that way, or in a simpler way, I could just write it as t sub n equals 6n. And then to verify that it works, I would simply take one of these terms, maybe this one, and plug in the 4 for the n and see if I get 24. So it'd be 6 times 4, which is obviously 24. It checks. So I know that my equation is correct. For another example, the bottom of the notes, again, we're going to subtract the numbers from the sequence in the numerator. So I'm going to take 23 minus 8. I think it's always a good idea to start with the larger term and subtract the smaller. And then on the bottom, I'm going to take 5 minus 2. So it's just like finding slope from points, which we did a couple units ago. So 23 minus 8 is 15. 5 minus 2 is 3. And 15 divided by 3 is 5. So this sequence is increasing by 5. So to fill in the missing terms, I would say 8 plus 5 is 13. 13 plus 5 is 18. 18 plus 5 is 23. 28, 33. And then to go backwards on the table, instead of adding 5, I would subtract 5. So 8 minus 5 would be 3, and 3 minus 5 would be negative 2. So to write the equation of the sequence, I would say t sub n equals, the change is 5, so that's 5n, and then the 0 term is negative 2, so I'd say 5n minus 2. To prove that it works, I would just pick a term, let's pick this one, plug in a 4 into the equation, okay, and what I'm hoping to get is 18 when I plug in a 4. So 5 times 4 is 20, 20 minus 2 is 18, so I did get the correct answer, so this is the correct equation. It's always a great idea to check your equation to make sure it worked. Here's the third example. Remember, if you've already understand the concept, you could stop watching the video at this point. But if you want another practice round here, I would take 22 minus 10, and I would take 6 minus 2. 22 minus 10 is 12, 6 minus 2 is 4, 12 divided by 4 is 3. That means this sequence is increasing by 3. So 10 would become 13, 16, 19, 22 makes sense, and 25. Going down the table, I would subtract 3, so that would be 10 minus 3 is 7, 7 minus 3 is 4. The equation then would be t sub n equals the change, 3n, and then the 0 term plus 4. To verify that it is correct, I would pick a term. Let's pick 3 this time. So I'm going to plug a 3 in for the n and see what I get. So 3 times 3 is 9. 9 plus 4 is 13, which is what I should have gotten. So that means I am right, and that is the correct equation. And the last one, again, I'm going to subtract 69 minus 34 and 7 minus 2. So 69 minus 34 is 35, and 7 minus 2 is 5. 35 divided by 5 is 7. So my change is plus 7. So let's fill in the sequence. 34 plus 7 is 41. 41 plus 7 is 48. 48 plus 7 is 55. 55 plus 7 is 62. 62 plus 7 is 69. So it's working. 34 minus 7 would be 27, and minus 7 more would be 20. So my equation would be T sub n equals the change, 7n, and then the 0 term plus 20. Let's check it. I'm going to plug in this one this time. So I'm going to plug in a 4, and obviously I'm hoping to get 48. So 7 times 4 is 28. 28 plus 20 is 48. That's what I should have gotten, so I know my equation is correct.